to start by giving you any background information. I want to go right to the first example, and I want you guys to tell me why it's impossible right now to do. And maybe I can help you. Okay, first little thing here. We're going to see some new notation. All right, new notation. I am no longer going to call this segment BC. I'm going to refer to it as side A. Why side A? Because it's across from angle A. All right. I am not going to refer to this as segment AB. I'm going to refer to this as side C because it's across from angle C. So when you see the lowercase letters now, that means the side across from that angle. All right, the side across from that angle. So if you see, in a couple minutes, we're going to see lowercase t, which tells me that's across from angle T. All right. So it says solve the triangle. We have seen those directions before. Solve meaning finish it. Find all the sides and angles. You guys should be able to at least do one thing for me. In this triangle, I've given you two angles and one side. What can you find now? The third side. The third angle. So go ahead and find the third angle. We can at least do that. And that third angle will be 20, 30 degrees. Yep. All right, well, now let's talk. Why am I not allowed to use sine, cosine, or tangent to find the missing sides, Emma? It's not a right triangle. And you guys probably never thought about it when we were doing this, but doesn't that stink that you have to have a right triangle to do all this? Why can't I just have any triangle and find any side, like this problem? Why do I always need a right triangle? What just happened? What just happened? Okay, anyway, I don't know what that was all about, but thanks, Will, for the contribution. Is this just yell out random geometry vocab now? Nets! We're good. All right. Okay, what I'm going to show you today is you can have any triangle and find any side or angle. That's what I'm going to show you today. Okay, doesn't matter if it's a right triangle or not. But I can't use sine, cosine, tangent. What I'm going to show you is what's called the law of sines. Okay, the law of sines. Here's what it is. It's a proportion. It's a proportion. Very easy one. Nothing tough to memorize. Here's what the proportion says. If you take any side in a triangle, side A, over the sine, law of sines, the sine of its angle. So side A over the sine of A. That ratio is equal to any other side over the sine of its angle. How many sides and angles are in a triangle? 3. So I could extend this proportion to say C over sine of C, but please realize, guys, you're only going to use 2 at a time. We're not going to solve an extended proportion with 3 ratios. Go up here. Do you guys know a side and an angle across in that triangle? What's the side you know? So that ratio, 28 over, what's the angle across? 40, but I'm going to put sine 40. That ratio is equal to, we got to find either side, so it doesn't matter. Give me a side we want to find here. A. Side A over, what's the angle across from side A? Sine of 110. And how have we been solving proportions all year long? Okay, so let's cross multiply. Sine of 40 times side A equals 28 times the sine of 110. How are you going to get A by itself? 11. How do I want to get A by itself? Yep, divide by sine 40. And you guys can put this right in your fraction template if you have one. And side A will be equal to, and let's go, yep, round your final answers to the nearest tenth. And nearest tenth, the value of side A, 14, nearest tenth. 14, not here. 2? 40.9. Thanks, 40.9. All right, what about side C now? Side C, because it said solve it, so I got to find all of missing sides. My suggestion to you guys, you don't have to listen to me, but my suggestion, keep the original ratio you were given, 28 over sine 40. So 28 over sine 40. What's the ratio going to look like involving side C now? Here you go, 15. Of, we found that angle earlier? 30. Got it. And now I can cross multiply. Divide both sides by 19, divide by. Yep. And to the nearest tenth. 16. And letting you know, law of sines, any triangle. Right triangle or not a right triangle, it'll work for anything. As long as, hey, hold on, what were you given at the beginning? How many angles? 2 angles and 1 side. Okay, what if I'm not given that? That's tomorrow's topic. All right, so 2 angles and 1 side, if it's a right triangle or not, you can always apply law of sines. All right, here you go. Sorry, you had to draw your own diagram here. Triangle DAT. I'm waiting. I'm waiting. That triangle? Yeah. Oh, no, no. No, nothing? All right, never mind. Never mind. It was pretty good, I know. Lowercase t, that's what? Side across from? Angle t is 21. I'm asking you guys just to, not to solve it, just to find d. So what am I asking for? The side across from? Angle d. Hey, 2 angles and a side. Looks like law of sines I can use, but we're going to be in a little problem situation here. Woo! I know d is across from sine of 27, but then I have this 21, and I'm not going to put sine of 105. It's not across from 105. I need the angle across from it. Any help? 180 minus the 2 angles. Yeah, that's not really a big problem, but. So what am I going to put it under? 6, when you're ready, what am I going to put 21 under or over? Sine of, yep. Make sure you remember your signs. Now I can cross multiply. In this case, what am I dividing both sides by? 10? All right, let's do it. And we're going nearest integer here, integer, whole number. Three, what do you got for me? Thank you. One more on your own or in your groups. Let me see the answer. Once I give you the okay, we can go on to the homework. Solve the triangle, so find all missing sides and angles, please.